Hey everyone, and welcome to another deep dive with us. This time we are going to be tackling something truly out of this world.
Out of this world is right, because today we're talking about colonizing Mars.
I know a lot of you out there listening are big fans of space exploration.
And always up for learning something new.
So today, we are going to try and get you up to speed on what exactly NASA is doing to prepare for a mission to Mars.
And why some folks are so passionate about the idea of turning the red planet into humanity's second home.
We have two great sources to help guide us today.
One is a recent report that looks at NASA's progress and challenges in getting to Mars.
And the other is an article by Robert Zubrin, who is a major advocate for Mars colonization.
It lays out a lot of his arguments for why we need to make this happen.
Okay, so first things first, let's talk about Mars itself.
It's pretty far away, right?
Yeah, it's not exactly a weekend trip.
It is definitely not a weekend trip. And that distance is something we really need to grasp, I think, to appreciate the scale of what we're talking about here.
Good.
Depending on where Earth and Mars are in their orbits, the journey could be anywhere between 33 to 249 million miles.
Whoa.
Imagine trying to plan that road trip.
Yeah, that's a lot of snacks.
A lot of snacks, a lot of podcasts.
A lot of bathroom breaks.
Yeah, okay.
But I guess distance is just the tip of the iceberg when it comes to actually getting to Mars, right?
Exactly. Mars itself isn't what you call a welcoming environment.
Wow.
For starters, the atmosphere is incredibly thin.
Okay.
And it's mostly carbon dioxide, which means we'd have very little protection from all the harmful radiation coming from space.
That sounds a bit concerning. How does that compare to the radiation we experience here on Earth?
It's significantly higher.
Okay.
We're talking about levels that could be seriously dangerous to astronauts, especially over time, like a much higher risk of cancer, if we can't find ways to shield them effectively.
So radiation is one thing, but what about the temperature on Mars?
Ooh, yeah. Temperatures swing wildly there. I mean, we're talking from a bone-chilling negative 284 degrees Fahrenheit to a relatively mild 86 degrees.
What's negative 284? That's just mind-bogglingly cold.
It is. And that extreme temperature range, combined with the whole no breathable atmosphere thing and the lack of a global magnetic field like we have here on Earth, makes Mars a very, very challenging place to try and live.
So given all of those hurdles, what are some of the things that NASA is specifically working on to make a Mars mission even possible?
I mean, it's got to be way more complicated than just building a rocket and blasting off.
Oh, yeah, way more. It's a multifaceted challenge.
Absolutely.
It requires solutions to problems we've honestly never even had to deal with before.
We already talked about the radiation, which is a major concern for astronauts on a long-duration mission.
Right.
But there's also the isolation and confinement factor.
Okay.
Imagine spending more than a year cooped up in a spaceship.
Oh, gosh.
With the same small crew.
Yeah.
That kind of isolation can really affect you mentally.
Yeah, I can only imagine.
So psychological support is absolutely crucial.
For sure. Even with incredible views of space, being that far away from everyone and everything you know.
Yeah.
That's got to be really hard.
It is. And then we have to deal with communication delays.
Okay.
With signals traveling at the speed of light, it can take up to 22 minutes for a message to go between Earth and Mars each way.
Ooh.
So say goodbye to any kind of real-time conversation.
Wow. That's a long time to wait for a response. So it seems like any mission to Mars would require a ton of planning in advance, and the astronauts would need to be able to make a lot of decisions independently.
Exactly.
Yeah.
They would need to handle a lot of situations on their own without being able to get immediate feedback from mission control.
Right. What about the difference in gravity between Earth and Mars?
Oh, yeah. That's another big one.
How much of a difference are we even talking?
Mars has only about 38% of Earth's gravity.
Okay.
And that lower gravity would affect everything. How astronauts move and exercise, how their equipment operates. We have to design everything with that in mind.
It's amazing how something we totally take for granted here on Earth, like gravity, becomes a major thing we have to figure out when we go to space.
Yeah.
So what else? What other big challenges is NASA working on?
Well, there are the environmental hazards specific to Mars.
Oh, right.
Like dust storms.
Okay.
They can engulf the entire planet.
Right.
And they can last for months.
Oh, wow.
And they block out the sun.
Really?
So yeah, we have to design habitats and systems that can withstand those.
That's a big one.
It is?
So it sounds like NASA has a lot on their plate.
They do.
But I am kind of curious about some of the technology they're developing.
Oh, yeah.
What are some of the coolest things that they're working on right now?
There are some amazing innovations in the works. One area they're focusing on is advanced propulsion systems.
Okay.
You know, to try and cut down that travel time.
Right, because The less time they spend traveling,
Yes.
the less exposure they have to radiation.
Exactly. And all the other hazards of deep space.
Makes sense. So what are they working on to make that happen?
Well, one concept they're exploring is nuclear thermal propulsion.
Nuclear thermal propulsion?
Yeah.
That sounds intense. How does that even work?
It's actually a pretty efficient way to travel through space. Essentially, a nuclear reactor heats up a propellant,
Okay.
like hydrogen,
Okay.
to extremely high temperatures. And that creates this really powerful thrust
Okay.
that can move a spacecraft much faster than our conventional chemical rockets.
Wow, so it's like a supercharged engine for spaceships. That's incredible.
Would be much.
What about landing on Mars?
Yeah.
Landing a spacecraft safely on Mars with such a thin atmosphere.
Uh-huh.
That's got to be pretty tricky, too.
It is a big challenge.
Okay.
And one of the solutions that NASA is working on is inflatable heat shields.
Wait, inflatable heat shields? So like a giant airbag for a spacecraft?
Exactly.
That's wild. Why would they do that?
Well, it sounds a little strange, but it's a really clever way to create a much softer landing in that thin atmosphere.
Okay.
Instead of relying on those rigid heat shields that can be very heavy, these inflatable ones would deploy during atmospheric entry, creating a much larger surface area to slow the spacecraft down.
That's amazing. So they're working on faster travel and safer landings.
Yep.
But what about just surviving on Mars itself?
Right.
What kind of technology do we need for that?
One of the most important areas is figuring out how to use the resources that are already on Mars,
Okay.
rather than relying on supplies that we ship from Earth. And that is where this concept of ISRU comes in.
ISRU. What is that?
It stands for In Situ Resource Utilization.
Okay.
And it's basically about living off the land, but on Mars.
So making the most of what's already there.
Exactly. Scientists believe that Martian soil has water, ice, and minerals that we could extract and use to make essential supplies, like oxygen for breathing,
Okay.
water for drinking, and even growing crops, and even fuel for the rockets.
Wow, that's like space-age survival skills. That would be crucial for staying there for a while, right?
Yeah, absolutely crucial. And then there's also the challenge of generating power on Mars. For that, they're developing these compact fission reactors to make sure there's a reliable source of power,
Okay.
especially during those dust storms that can block out the sun for months at a time.
So portable nuclear reactors for Mars. That's impressive.
It is. And when it comes to habitats, they're working on designs that can protect astronauts from radiation, maintain a livable temperature, and provide all the life support they need.
Right. So like a little home away from home.
Exactly. They're even looking at inflatable habitats that could be transported easily
Okay.
and deployed on the surface.
Wow. It's incredible to think about how complex it is to create an environment like that on another planet.
It is.
With all of this technology still being developed, how is NASA actually getting ready for a Mars mission right now?
Well, that's where the Artemis lunar missions come in. They're using those missions as a testing ground for a lot of the technology and procedures that'll be needed for a mission to Mars.
So the moon is kind of like a stepping stone?
Exactly. Think of it as a stepping stone to Mars.
Okay. What are some specific examples of things they're testing out with the Artemis missions?
Well, one of the key areas is life support systems.
Okay.
They're testing those advanced water recycling systems we talked about
Okay.
and techniques for generating oxygen from lunar resources
Wow.
and even trying to grow food up there.
Wow. So it really is like they're learning to live off the land, but on the moon.
Exactly.
And all of this is going to help them learn how to do it on Mars.
Yeah. They're also looking at the effects of long-duration space travel on humans,
Right?
figuring out how to maintain morale in isolated environments and how to deal with those communication delays and the psychological impact of being far from home.
Wow. It really sounds like Artemis is like a full dress rehearsal
It is.
for a future Mars mission.
It is. It lets NASA kind of work out the kinks in a much less challenging environment.
That's fascinating.
Yeah.
But I'm curious, why Mars? Why not focus on the moon? It's so much closer. Seems like it would be a more achievable goal.
That's where Robert Zubrin comes in
Okay.
and his arguments for colonizing Mars.
Okay.
He lays out a pretty compelling case for why Mars is the ultimate frontier for humanity.
I'm intrigued. What are some of his main arguments?
Well, one of his core arguments is that Mars has the resources humans would need to actually be self-sufficient.
Okay.
We're talking about water ice that can be melted and purified, essential elements in the soil that we could use for agriculture and building, and even the potential to generate energy from things like solar and geothermal sources.
So unlike the moon, where you'd be more dependent on Earth for resources, Mars gives us a chance to be more independent.
Exactly.
Okay.
And Zubrin sees Mars as more than just a temporary outpost. He thinks a real civilization could grow there. He imagines large-scale agriculture and manufacturing and new technologies, basically a whole new branch of humanity taking root on Mars.
That's quite a vision.
It is.
He's definitely thinking long-term.
Oh, he takes it even further. He believes Mars could become a trading hub for the whole solar system.
Oh, hold on. Interplanetary trading. What would they even trade?
He suggests Mars could export deuterium, which is this rare isotope of hydrogen that's used in fusion reactors.
Okay.
There's also potential for mining precious metals and other things that are scarce on Earth. And Mars could even be a supply station for missions that go further out, like to the asteroid belt.
So not just a destination, but a jumping off point.
Exactly.
I've also read that he compares Mars to North America in the age of exploration.
It's an interesting comparison.
It is. Can you elaborate on that a little bit?
He argues that Mars, like North America back then, is full of potential for growth and development. It's a place where a new chapter of human history could unfold, driven by the same spirit of innovation and self-reliance that made early America what it was. The moon, on the other hand, is more like Greenland, closer, but ultimately limited in its resources and potential.
So if I'm understanding this correctly, Zubrin is saying that Mars is a true fresh start.
Yeah.
A chance to build a new society from scratch. That's a pretty powerful argument.
Yeah.
But how soon could we realistically see this happen?
Well, NASA's current goal is to launch a crewed mission to Mars sometime in the 2030s.
So that's not that far off. But is that really a realistic time frame given all the things we've talked about?
It is definitely an ambitious goal. And there are still lots of technical, logistical, and financial things to figure out. But with commitment and investment, it's definitely possible.
And what about Zubrin's vision of a self-sustaining Martian civilization? How far off is that?
That is a much longer-term goal, one that would likely take many decades, if not centuries, to achieve. It would require humans to be on Mars permanently, building infrastructure, developing agriculture, and essentially terraforming the planet to make it more livable.
So not something we'll see in our lifetimes, but something we can work towards.
Exactly. Every mission, every experiment, every new technology brings us closer to making that vision a reality. It's a legacy that we can all be a part of.
And that brings us back to the big question. If Mars is truly the next frontier, what role do you see yourself playing in this story?
It's something worth thinking about, isn't it?
Yes.
Whether it's supporting space exploration efforts, pursuing a career in science or engineering, or just inspiring others with the wonder of the cosmos, there are so many ways to be part of this journey.
That's a great point. It's not just about the astronauts and scientists. It's about all of us embracing the spirit of exploration and pushing the limits of what we can do.
And I think that's what makes this whole thing so exciting. It's not just about getting to Mars, it's about what we become as we try to get there.
I love that. Now, I know we've covered a lot of ground here, but this is just the beginning of our deep dive into Mars.
There's definitely a lot more to explore. So what has stood out to you so far?
Honestly, it's just the massive scale of it all.
Yeah.
The idea that we're talking about sending people millions of miles away to a planet that's basically trying to kill us.
Right.
And then figuring out how to make it so they can survive.
Yeah.
Not just for a short visit, but for generations.
It is pretty amazing.
It's mind-blowing.
It is a testament to human ingenuity, though.
Yeah.
I mean, we've always been driven to explore.
Yeah.
To see what's out there and push the limits of where we can go.
It's like that's in our DNA or something.
It really is.
So I'm curious about the timeline we talked about earlier.
Yeah.
What are some specific things that NASA's doing right now to prepare for this mission in the 2030s?
As we mentioned, the Artemis lunar missions are a huge part of that. You know, it's not just about getting back to the moon.
Okay.
They're using the moon to test out the technologies and strategies we'll need for Mars.
So it's like a practice run.
Yeah.
Okay.
Yeah.
What are some examples of things they're testing specifically?
Life support is one of the top priorities.
Okay.
You know, keeping astronauts safe and healthy on a mission that could last years.
Right.
So they're experimenting with advanced water recycling systems, figuring out how to generate oxygen from lunar resources, and even growing food in these controlled environments.
Wow. So it really is like living off the land, but on the moon.
It is.
Fascinating. What else?
They're developing and testing new spacesuits that are more flexible and durable than the ones we have now.
Okay.
And robotic systems that can help with exploration and construction.
Yeah.
And even 3D printing techniques so they can create structures using the materials they find on the moon.
So they're essentially learning how to build a mini colony on the moon. Wow. And that will serve as a blueprint for what they do on Mars.
Pretty much. And they're also looking at the psychological aspects.
Oh, right. How being in space affects you mentally.
Exactly.
Yeah.
You know, how to keep the crew happy and working together in those isolated and confined environments.
Yeah.
How to deal with communication delays and the psychological impact of being so far from home.
Sounds like they're thinking of everything.
They are trying to, because a mission to Mars will be unlike anything we've ever done before.
For sure.
It'll require a level of preparedness and resilience that's just off the charts.
Speaking of preparedness, something that's been on my mind is the travel time.
Yeah.
We've talked about how long it takes to get to Mars.
Right.
Even with those advanced propulsion systems.
Uh-huh.
Is there any way to make that journey faster?
It's one of the biggest challenges for sure,
Okay.
and it's something a lot of researchers are focused on. We talked about nuclear thermal propulsion.
Right.
Which could cut months off the travel time. But they're also exploring some even more futuristic concepts.
Like what? Give me a glimpse into the future of space travel.
One idea that sounds like it's straight out of science fiction is solar sails.
Oh, yeah, solar sails. I think I've heard of those. How do they work?
It's actually a pretty simple concept. You have a big reflective sail
Okay.
that unfolds in space, and it uses the pressure of sunlight to push the spacecraft.
Okay.
Sort of like how a sailboat uses the wind.
Wow. So it's like riding a sunbeam to Mars?
Pretty much. Now, solar sails don't provide a ton of thrust, but they can speed up a spacecraft gradually over really long distances, and eventually they can reach very high speeds.
That's incredible. Are there any other cool propulsion systems on the horizon?
Another interesting one is ion propulsion.
Okay.
It uses electricity to accelerate ions, which creates this very gentle thrust.
Okay.
But it's continuous, and it can be sustained for years.
So maybe not as fast as nuclear propulsion, but more efficient for certain types of missions.
Exactly. It's actually already being used on some robotic spacecraft.
Wow. And it could definitely play a role in human missions someday.
That's exciting. Who knows what other breakthroughs might happen in the next few years.
Yeah.
But for now, I want to switch gears a bit.
Okay.
And talk about something we touched on earlier. The whole idea of colonizing Mars.
Okay.
Creating a human civilization on another planet. That's such a bold idea. What would be some of the biggest hurdles we'd need to overcome to actually make that happen?
There are a lot, and they're not just technical. There are social and ethical hurdles as well.
Right.
One of the most fundamental is terraforming.
Terraforming. Okay, remind me what that is again.
It's the process of transforming Mars to make it more like Earth.
Okay.
So basically making it more habitable for humans.
So that would involve things like making the atmosphere thicker,
Yeah.
warming up the planet,
Yeah.
creating bodies of water.
Exactly. It would be a massive undertaking. And there's still debate about whether it's even possible, let alone ethical.
It sounds like it's straight out of a science fiction movie. It does, but even if we could do it, it would probably take centuries.
Yeah.
Maybe even millennia to get it done.
Wow.
And in the meantime, we'd still need to figure out how to create life support systems that can keep a human population alive.
Right. Without relying on supplies from Earth.
Exactly. We'd need to be able to produce our own food and water and air and pretty much everything else.
We need to be totally self-sufficient.
We would. And then there's the psychological and social side of things.
How do people handle living in such an isolated and confined environment?
Exactly. Maybe for generations. How do you create a society that can thrive under those conditions?
Yeah.
How do you prevent conflicts? These are questions we're just starting to think about.
It's like a giant social experiment.
It is. And we can't forget that we wouldn't be starting from scratch.
Meaning?
We'd be bringing all of our human baggage with us.
Yeah.
Our history, our prejudices, our conflicts.
That's a really good point. It sounds like building a successful colony on Mars would take more than just technical skills.
Oh, yeah.
We'd also need to understand human nature
Yes.
and be able to create a more fair and sustainable society than what we have here on Earth.
I couldn't agree more. It would push us to our limits in every way.
But isn't that part of what makes it so compelling? The idea that we could learn from our past mistakes.
Yeah.
And create a better future for humanity. Maybe even discover something new about ourselves in the process.
Absolutely. It's a challenge that's worth aiming for.
Okay, so we've talked about the technology, the challenges, the big vision.
Yeah.
But let's get down to the everyday stuff.
Okay.
What would it actually be like to live on Mars?
That's a great question, and one that scientists and science fiction writers have been thinking about for decades. Let's start with the basics.
Okay. So what would a typical day on Mars look like?
Well, first of all, a Martian day is called a sol.
A sol.
Yeah, and it's about 40 minutes longer than an Earth day, so we'd have to adjust our internal clocks a little bit.
I don't think I could handle that. What about gravity? You mentioned earlier that Mars has lower gravity than Earth. How would that affect us day to day?
It would change everything we do.
Right.
Walking, running, lifting objects, even sleeping.
Really?
It would all feel different.
Okay.
Our muscles and bones would eventually adapt, but there would be both good and bad consequences to that.
Like we might be able to jump higher and lift heavier things.
Yeah.
But our bones might get weaker over time.
Right.
Interesting. So it would also affect how we build things on Mars.
Oh, yeah, for sure. Structures could be taller and lighter, but they'd also need to be designed to withstand the lower gravity.
That makes sense. Okay, what about the environment?
Yeah.
What would it be like to go outside on Mars?
Well, Mars doesn't have a breathable atmosphere like Earth does.
Right.
So you'd need a spacesuit anytime you went outside. And those can be bulky and hard to move around in.
So no relaxing walks without a spacesuit.
Not unless we find a way to terraform the planet. And even then, the Martian landscape is pretty different from what we're used to.
Yeah. Dry and dusty and rocky.
Okay.
Vast plains, towering volcanoes, canyons bigger than anything on Earth.
Wow. It sounds beautiful, but also kind of desolate.
It is both. And the colors are very different from Earth. The sky on Mars is this pale butterscotch color during the day, and the sunsets are often bluish.
Wow.
Because of the dust particles in the atmosphere.
That sounds incredible, like a photographer's dream.
It does.
What about the weather? Would we still have seasons on Mars?
Mars does have seasons.
Okay.
But they're much longer than on Earth because it takes Mars almost twice as long to go around the sun.
Okay.
And the temperature swings are way more extreme.
Okay.
Especially at the poles where it can get hundreds of degrees below zero in the winter.
Brr. We'd need some serious heating to survive that.
Definitely. And then there were those dust storms.
So
those can engulf the entire planet.
Yeah.
Blocking out the sun for months.
It doesn't sound like a picnic on Mars.
It's not.
What about food? What would we eat? Well, we talked earlier about developing sustainable agriculture.
Right.
And scientists are already working on growing crops in Martian soil right here on Earth. The results look good so far.
So maybe we could have Martian salads one day.
Maybe. We would probably also rely on things like insects for protein.
Okay.
And lab-grown meat and supplements to make sure we get all the nutrients we need.
It's definitely a different type of cuisine than we're used to.
Yeah.
But I'm open to trying it. What about water?
Water would be a really precious resource on Mars, at least in the beginning. We'd have to collect and recycle every drop.
That makes sense. So living on Mars would force us to change how we think about resources.
Yeah.
To be more efficient and sustainable in everything we do.
Exactly.
Yeah.
And that change in perspective would be one of the biggest results of living on Mars.
It's like an evolution of our values.
It kind of is.
We'd need to work together more. Focus more on the well-being of our society and the planet. That's pretty inspiring. So it seems like there would be a lot of opportunities for humans to learn and grow from living on Mars.
There would.
But what about the mental and emotional impact?
Yeah.
How would we adapt to living in such a different environment?
Psychologists are studying that very carefully.
Okay.
The isolation, the confinement, the lack of familiar things, the constant danger.
Right.
All of those could affect our mental health.
For sure.
We'd have to find new ways to cope.
Okay.
New ways to stay connected with each other and with Earth.
I think virtual reality could play a role in that.
Yeah.
Maybe giving people a way to experience things they miss.
Right. And staying in touch with loved ones back home would be essential.
Yeah. But wouldn't that sense of wonder, that excitement of exploration, help offset some of those challenges?
I think so. There's something inspiring about being on a frontier.
Yeah.
About pushing the boundaries of human experience. And the Martian landscape itself would be incredible to explore.
Yeah.
Imagine being the first humans to climb Olympus Mons.
Wow.
Tallest volcano in the solar system.
Yeah.
Or exploring those giant canyons, the Valles Marineris.
That would be amazing. It sounds like living on Mars would have a really complex psychological impact.
It would.
Both positive and negative.
Yeah.
But something I keep coming back to is this question of purpose.
Yeah.
What would our purpose be on Mars? Why would we be there?
That's a big question. And I think each person would have to answer that for themselves. Some people might find their purpose in scientific discovery, pushing the boundaries of knowledge.
Right.
Others might find it in building a new society.
Yeah.
Creating something better for future generations.
And some might find it in the exploration itself.
Yes.
Yeah.
Expanding our understanding of where we fit into the universe.
That's a great point. It reminds me of something Zubrin said in his article. He argues that Mars isn't just a destination, it's our destiny.
Right.
He believes that becoming a multiplanetary species is crucial for the survival of humanity.
It's a powerful argument. He sees Mars as a backup plan in case something terrible happens to Earth.
Oh, wow. A lifeboat for humanity.
Exactly. But he also sees it as a starting point for going even further, a stepping stone to the stars.
That's a pretty amazing vision. It makes you feel hopeful about the future.
It does. It makes us think bigger and imagine a future where we're not limited to just one planet.
I'd love to be part of that future.
Yeah.
But for now, let's get back to the present.
Okay.
We've talked about the technology, the challenges, the vision. What about the impact on us as humans?
Right. And up next, we'll look at some of the ethical considerations and explore the potential for both conflict and collaboration as we head into this new frontier.
So we've talked a lot about the hows and the whys of getting to Mars and colonizing it, but what about the who?
The who.
Yeah. Like when we do eventually get to Mars, who gets to call the shots? Who makes the rules?
That's a big question.
It is.
And there isn't one easy answer. Some people think Mars should be its own separate nation. Okay.
With its own government? Others think it should be an extension of Earth's systems.
So we're basically talking about space politics.
Yeah, kinda.
That's wild to think we're already having to deal with this stuff before we've even set foot there.
It shows how complex this whole thing is. It's not just about the technology.
Right.
It's about the social and political and even philosophical aspects too.
Yeah. We're talking about building a whole new society.
We are.
From the ground up.
And how we govern it is super important.
I bet there are a lot of ethical questions too.
Oh, absolutely.
Like who actually gets to go to Mars?
Yeah.
And who benefits from the resources there?
It would be easy to just repeat the same inequalities we have here on Earth.
Yeah.
Where the wealthy and powerful get all the advantages.
Right. It's like all the problems of Earth, but in space.
Exactly.
And that's why it's so important to be talking about all of this now.
It is. We need to be really thoughtful about the values we want to guide us.
Yeah.
As we move into this new frontier, it feels like we have an opportunity to do things differently.
We do.
To create a society on Mars that's more fair and just.
I agree. We have a chance to learn from our mistakes and build something better.
Okay, so we've talked about governance and ethics. What about conflict?
Conflict.
Yeah, like I imagine there could be disagreements.
Oh, yeah.
Maybe even rivalries between groups on Mars.
For sure, especially if resources are limited.
Right. I mean, the history of exploration and colonization here on Earth is full of conflict.
It is, over resources and territory and power.
It's a reminder that we might take those same tendencies with us to space.
We might. But we're also capable of amazing things when we work together.
Like surviving on a harsh planet millions of miles from home.
Exactly. That shared challenge could actually bring us together.
And create a stronger sense of unity than we've ever had on Earth.
Possibly. It's almost like Mars could force us to confront our weaknesses.
And work together to create a better future.
It's a powerful thought. It shows how transformative this whole thing could be. Going to Mars isn't just about expanding physically.
It's about expanding our minds and what we think is possible.
Exactly. Maybe even rediscovering what it means to be human.
That's a great way to put it. So as we wrap up this deep dive, what's one key takeaway you'd want our listeners to leave with?
I think the most important thing to remember is that going to Mars and colonizing it is a choice. It's not inevitable.
Okay.
And it's a choice that comes with a huge amount of responsibility.
We're not just talking about the technical stuff, but the ethical side too.
Absolutely. And it's a decision we need to make together with a clear understanding of what's at stake.
Well said. I think this deep dive has given our listeners a lot to think about. The challenges and possibilities of going to Mars, the technical hurdles, the social and ethical considerations.
It's a topic that really makes you think big.
It does. So to everyone listening, Keep exploring this topic.
Keep asking questions.
And keep imagining the future.
Because the story of humanity on Mars is still being written.
And we can all play a part in it.
We can.
Thanks for joining us on this incredible deep dive.